So today we are going to talk about integrals. Before we talk about integrals, I want to ask you some questions. Do you know what differential is? Okay, you must know what differential is, because if you don't, please view some previous video to know what differential is. But here I will still review some differential here. Okay, let's begin. Differential. A differential is differential we can represent here. So the differential of y is dy, and the differential of x is dx, and we usually represent dy equals to the dy over dx times dx. Okay, so let's do some examples. You can first try on your own. Okay, just give you a few seconds to pause the video and to do this on your own. Okay. So for the first one, y equals to 2x plus 1 here. Okay, where's the pen here? So the first one, y equals to 2x plus 1. Okay, what do you think? Okay, first write dy over dx is equals to 2 times x 1 minus 1 plus 1 times 0. Okay, so which is equals to 2 plus 0 is equals to 2. The first one answer is 2. Okay, and for the second one, y equals to the natural log of 2x. dy over dx, we have to write every time this thing in differential. Okay, so dy over dx of natural log 2x. So we first write 1 over absolute value of 2x, and don't forget the chain rule. Okay, we have a 2 here, so we times 2, and then it is equals to 1 over absolute value of x, because we can eliminate the 2 here. That's it. That's the answer. Okay, got it? Wonderful. Next slide. So area under the curve. We want to understand the integral, we have to understand the area under the curve. And this is what integral do. So a tiny bit of area, just imagine it's a very tiny bit of area. It's like here, okay, which is dA is equals to fx times dx. So okay, rectangle. Okay, it could be just this small, right? Anyway, so the area under the curve between A and B, which is another area, we just use another color here. All right, let's choose blue here. Okay, so the area from A to B, the blue one here. Okay, it is the integral from A to B of fx times dx, and this one can represent here. We can also write this area A. Okay, it is area A, blue here. Okay, so if we let the derivative of the capital X equals to lowercase fx, and we can write here, so the derivative of the capital F equals to the lowercase f x times dx. So here the d capital F equals to dA, which is the tiny little bit area of the rectangle. Okay, as we write here. Okay, and so the capital Fx equals to the integral of fx dx, and in here the capital Fx is the antiderivative of the lowercase of fx. Alright, it is antiderivative because the antiderivative we can get it equals to integral. Alright, integral. It is the antiderivative. Okay, so this type of integral is called the indefinite integral. This type of integral is called the indefinite integral. What do you mean indefinite integral here? Okay, it just don't contains the value from a to b, c to d, blah blah. Alright, it contains no value here. Alright, don't like this one. It contains from a to b, but this one nothing. Alright, pretty obvious. And then we computing the indefinite integral. Just take the antiderivative of the lowercase fx. Alright, take in. So we find the indefinite integral. So the integral and the antiderivative is basically the same thing. Alright. Okay. So for this one, here's an examples of the antiderivatives. Alright, which is integral. You know what I mean. So for the integral of x to the n times dx, it is equals to x to the n plus 1 over n plus 1. Okay. So and c here, c is a constant. So for most questions, we don't need to worry about c because they didn't give us a certain value of c, which is so when you see f0 equals to a certain constant here, this is the c value. Okay, so f0, okay, it is the c. The whole thing is equals to c. This one is equal to c actually. I don't mind. So basically, we just need to remember the first thing here, and for some special questions, don't forget to add c. Okay, so most situations we don't have to add c because they didn't give us a c. Okay, so for the second one, the integral of 1 over x dx is equals to the natural log of the absolute value of x, of course, plus c. And the third one, it is cosine x dx integral equals to the sine x plus c. But this two is a little bit important here, so you better remember these two because it's the triangle questions. Okay, so the integral of sine x dx equals to negative cosine x plus c. Sine x, okay, negative cosine x plus c. So and for the last one, the integral of e to the x dx is equals to e to the x plus c here. It's basically the same thing because as we mentioned before, or maybe you know, so the derivative of dx over dx is equals to dx. Alright, this is the same thing. So the integral of dx e to the x dx is also equals to dx e to the x. Sorry. Okay. So here we come to the definite integral. Okay, we talked about indefinite integral. Remember that it doesn't contain value from a to b or c to d, blah blah blah. But here we have the value from a to b. So we first find the antiderivative of the fx dx, which is the capital F, and we plug in the upper one, which is b, and minus the lower one, which is the a here. So we just find the value of the definite integral. Okay. So let's see some practice questions. Okay. So for this one, the integral from 1 to 3 of x squared dx, it is equals to the integral 1 to 3 x squared dx equals to, just remember what I told you before. So this one over here is x to the n plus 1 over n plus 1. Okay, so here it is The 3 is just 2 plus 1, and 3 is also 2 plus 1 here, because we have an n of 2 here, and then also it is from 1 to 3, alright? So we just got 1/3 of the 3 cube minus 1 cube, which is equals to 27 minus 1 equals 26. So 26/3 is the answer here. You see, we don't have a C here because it doesn't tell us what f0 equals to. Okay, so the next one, a little bit tricky here. I hope you remember that. What is the integral of sine x dx? Right, it is the negative cosine x right here. So please remember this too. Alright, it's pretty important. Okay, so the integral from 0 to pi of sine x dx, it is equals to the negative cosine x from 0 to pi. Alright, so we just plug in pi first because it's the upper one, cosine pi, and the lower one, 0 minus cosine 0. Cosine pi is equal to -1, and cosine 0 is equal to 1, and -1 minus 1 is equals to the -2 here. Sorry, -2 here, and we find the -2, which is 2, obviously. Okay, so for this one, the answer is 2. Right, pretty simple, huh? And for the next one, what about definite integral? Alright, so in the graph, we can see the area under the curve, but over the x-axis as the integral from 0 to a is larger than 0. Okay, this integral is larger than 0, so it's over the x-axis and it's positive, right? But however, if the integral is negative, its area under the curve, under the x-axis, sorry, it is area under the x-axis here, right? You see what I'm marked here? Alright, we just use another different color here. So for this one, it's area under the curve, and for the upper one, it's positive. Okay, it's over the x-axis. Okay, so there's some rules for integrals that you might want to remember. So integral from a to b of fx dx is equal to the negative of integral from b to a of fx dx. Okay, you just inverse the upper one and lower one and just add a negative sign before. And for the second one, the integral from a to b of fx plus or minus gx dx. Here, we just can split up, which is integral from a to b of fx dx plus or minus the integral from a to b of gx dx. Okay, just split up. It's like this one, right? If you remember the combination rule. Okay. So for another one, the integral from a to b of fx dx plus the integral from b to c of fx dx. Just there, they have the integral that connect to each other. You know, a to b and b to c. The b here is the same thing, and we can just write the integral from a to c of the fx dx. So for the last one, we have a constant c here. So c is a constant, alright? I hope you remember that. C is a constant, but if you inside the integral, we can move it out of the integral, okay? And we can just write, so the integral from a to b of c times fx dx equals to c times the integral from a to b of fx dx. Okay, pretty simple, right? Okay, so here we come to the accumulation function. So it is a function defined by a definite integral. So it basically represents the area. It's equals to the integral from a to x of ft dt equals to the capital Fx minus the capital Fa. Okay, easy to remember. So we can also write in this way: capital Fx equals to Fa plus the integral from a to x of ft dt. Another way to write the same thing. So here it's also the same way to write the same thing, because f here, f is just ft dt. Okay, so the lowercase fx equals to the derivative of the capital F, so which is the integral from 0 to x ft dt. Okay, so let's do some practice here. Okay, so consider this one. What do you think? Can solve it? If you can, learn a lot. If not, maybe you want to go back and watch some of the videos to know how to solve these questions. Because everything here we already mentioned before. Okay? Okay. So for the first one, the integral from e to the x plus pi of dx. Okay? As we mentioned before, the integral of, so we can split up first, right? Remember the combination rule here, right? So we can split out into integral of e to the x of dx plus integral of pi times dx. So the first one, as we mentioned before, it is unchanged, so it's still ex. As we mentioned before, just ignore the e. No, not the e. Ignore the constant c here, because they did give us a value of constant c, and then we just plug pi times x, because we can see here that x equal to 0. So here we just is x 0 plus 1 over 0 plus 1, and that's x over 1, which is equals to x. So here's the answer for this one. Okay, so for the second one, they gave us the differential equation, which is the df over dx equals to the 3 times x squared plus 2x plus 1. And they gave us f0 equals to 2. Remember what I mentioned before. So whenever you see an f0, it is equals to c. So in this case, c is equal to 2 here. They gave us a c value, so we must include the c value in the answer. Okay, so they tell us to find the fx. They give us the differential of x. So basically, we still do the integral. We do the integral of 3x squared plus 2x plus 1. Don't forget a fraction here. Dx equals to okay, 3 times x 2 plus 1 over 2 plus 1, and plus 2 times x 1 plus 1 plus 1 here, and plus so 1 here, just the same thing here is x, and also 2 plus 2. So for this one, we can simplify it: 3, 3, 2, 2, and then we got x to the cube plus x squared plus x plus 2 as the answer for this one. Sorry. So this is the answer. You got it? Okay. If you got both of them right, you are mastered integral. Right? Master of integral. Okay. So thanks for watching here. If you want to learn some other things, you can continue to subscribe the channel and follow us. Alright? Thank you. Thank you for watching.